So, welcome to the live webinar. We've got a very special guest with the Engineers with Ideas group. Our special guest today is Josh Slingsby. He is a specialist in all things timber engineering. So, without further ado, let's crack on with it. Josh, can you just introduce yourself and tell us a little bit more about your history and background in the sector?
Yeah, no problem. Good morning, Dom. Good morning, everyone. My name is Joshua Slingsby. I'm a senior project engineer here at Urban Limited. So Urban are a specialist mass timber consultants, essentially, but we offer design, supply and installation services. So everything that we do is looking from the initial design stages in line with RIBA, whether it's stage 2, 3, all the way through to manufacture, stage 4 and 5. And then as well, we do the fabrication and procurement through to the installation on site. So everything we do is considering DFMA as well as design for installation. My personal experience, I originally studied architectural technology. So I actually started looking at more of sort of the detailed design of buildings, and through my undergraduate degree started looking at mass timber, looking at CLT. Most of my thesis was based around CLT and mass timber. That led to me taking on my initial role coming into the industry around 9 years ago was with KLH UK. So again, a CLT manufacturer in Europe, and then they have a design office in the UK, working on a more commercial role. Through that time, I took on structural engineering as a part-time master's, so developed and sort of sidestepped into the structural engineering world. And then I've been with Urban with near on 5 years now as a project engineer, and then going into senior engineering role. And yeah, so we supply projects, whether it's small residential houses through to multi-story residential, a lot of education. Most of our work's in the education sector, to be honest. And then everything in between, whether it's small,
Perfect.
commercial,
well, absolutely the person that we want to have on talking about mass timber.
Everything's centred around mass timber.
So just to dive straight into the questions then, I suppose what a lot of people wanted to know is aside from traditional timber engineering, what are the other options that are available if people want to use timber in engineering?
I suppose it's an interesting question. I suppose it depends on how people understand timber construction. You have traditional timber construction, so whether that's kind of stud framing all the way through to what you see in a lot of residential projects. And obviously you can go 2-3 stories even with traditional timber. Historical timber structures, we see that especially in the UK and in Europe, you see that everywhere, especially when you start looking at churches or Tudor buildings. So then you've got the whole conservation world around that and how you sort of restore historical timber structures, through to what we predominantly look at, which is mass timber. Now, mass timber is kind of all-encompassing for engineered timber solutions. So we predominantly deal with cross-laminated timber, so solid timber panels. So it's a panelized system. Easiest way to think about it is IKEA flat pack. So everything gets pre-manufactured in the factory. All your walls, floors, beams, column elements, all prefabricated, put on the back of a lorry, delivered to site, and we literally prepare the construction issue drawings, and they go to site, which are like your IKEA instructions, and they get to put them up. Feeling that the internet's just slowed.
Yeah.
Can you hear me now?
Sorry. I see that. So you were saying the easiest way to describe it was the IKEA flat pack.
Okay, I think I'm back. Apologies about that. Yeah, no, that's me. Exactly, essentially IKEA flat pack. So everything's pre-manufactured in a factory, put on the back of a lorry, delivered just in time to site. And essentially from our side, we'll produce essentially the IKEA instructions. They go to site and they install them. And traditionally, this is not a full prefabricated system with finishes. This is a structural system, solid timber panels, and we can show some images in a few moments just to demonstrate what that looks like. And that's kind of looking at CLT as a panelized system. Then you can look at glulam and beams, glulam columns, in terms of, again, another engineered product. So again, much more of a post and beam system, which can be integrated with CLT, for example. So we procure a lot of glulam frames as well. And then you start moving into sort of hybrid structures with that. And again, with a lot of these systems, you'll also potentially incorporate some solid wood, solid timber. And with that comes a lot of different species. So whether it's CLT, glulam, you can look at softwoods like spruce, pine, fir. Majority are spruce, so softwood coming from continental Europe, all the way through to whether you want it for the visual finishes or durability. You start looking sort of your larch, oak, birch, and you get in that side. There's additional sort of products out there as well. So you can start looking at LVL, so laminated veneer lumber, a lot closer to plywood in how it looks at its edges, but in terms of the structural qualities and how it's actually laminated, you're getting the additional structural capacity out of them. And so there's a lot of variety out there from the mass timber world, which will enable you to do a lot larger structures and larger spans, for example. You can go taller. So the largest project that we have on site at the moment is up to 7 stories, a multi-story residential, which is almost a little bit of I'll show you a couple of pictures if my internet will allow. Just open the picture and share. We go to share screen. See if this will. So for example, this is where we're at currently on site, and this is using CLT. There are some steel elements in there, there are some glulam elements in there, but this is predominantly a CLT frame. And this is to demonstrate sort of the size that you can go incomparable to traditional timber. So again, I think we're currently up to the 6th floor here, and it's a 7-story residential block in the centre of Cardiff. Full mass timber solution. Can I move across? Apologies, just closed that by accident. And to demonstrate the actual panelization, here you can see how everything is supplied and installed. And this is CLT panels. You can see the end grain here. The reason it's called cross-laminated timber is because essentially it's built up of multiple layers of what we call lamellas of different timber boards, and they're stacked 90 degrees to each other at each level, and then they're laminated. So with a glue and with a high pressure bonding, they're bonded together to give you a master panel. So for example, what you can see here, if you can see my cursor, it's on the left hand side, stretching all the way over here, which is around 10 meters, is a single panel that would have been craned into site, through to the element which is on the crane, which is an entire wall element with a door opening punched from there. So they manufacture panels 3 meters wide up to around 16.5 meters, depending on the manufacturer. So you get these large master panels, and then from there, we're able to either nest the individual panels through, and that's whether you're punching a door opening or window opening, or it can be cut and further nested and panelized. So the lintels are individual elements. There's a lot of ways that you can essentially work with them. And you can look to incorporate and coordinate your services. So all of your service runs are pre-cut in the factory. So for example, that's what these 2 little notches in the panel here are for some ductwork. And then on this project as well, because it's a multi-story and the use of the fire escape, the staircase couldn't have been a timber solution. So through what we do ourselves as well here at Urban, we design, manufacture and install steel elements where required. So again, a steel staircase which replicates as it goes through the building. So you can then see the contrast of materials, how that works together.
Well, thank you very much for
and how we're
sharing that.
able to integrate them
That
as
leads quite
close
nicely
to a
on
hybrid
to
structure in certain
the
elements.
next question that we've got in. A lot of people know that the mass timber is a more sustainable product, but I think people wanted to just know that how it actually reduces carbon footprint and how it actually promotes sustainability as well.
No, of course. I think, there's a lot of confusion with this, especially if you're in the engineering world and you're doing sort of carbon calculations. So there's quite a few. We won't get into that too much, but when you start using carbon calculations, there's a few things that, depending on the method, it might not account for when you look at timber. So obviously every material has some embodied carbon, whether it's through the extraction, through the processes that are being made. But the main thing with timber is it is a renewable resource, or typically, at least for everything that we do and all the materials and products that we use, they're coming from European manufacturers. So immediately they're coming from continental Europe, not the UK. And there's a key fact there for that is I think the UK has around 10 or 11% forest cover. Of that, how much of that is structural grade timber that can be used in the structural industry? Again, very minimal. Whereas countries like Austria, Germany, all the way up to Switzerland, a lot of that central DAC region at least is around 30 to 40% forest cover. And of those forestries, they are working plantation forests. So they're still old growth forests, but a lot of them are plantation forests. And then on top of that, they're managed forestries. So obviously FFC, PEFC. So in terms of how they're actually being managed, and they're not just, sorry, the phrase just lost me there, but in terms of the way that they're managed, obviously the way that they're harvesting the timber, so the way that they're actually cutting them down and replanting. It's in a managed process, so you don't just destroy complete areas of the forest without immediately replanting or doing patch. You're doing sort of local areas where you remove them. There's a lot of different ways within forestry of how they manage that to make sure that as much as you're always actually removing less than you're replanting, and so that you're keeping the cycle going. And that's one of the main things with timber there. And the reason for that, and the reason why this is then so sustainable, or essentially is a sustainable solution in comparison to other materials like steel, concrete,
Do a little bit there, Josh.
forestries
just go back on that last point.
So I'm seeing a spinning wheel on my screen. Can you still hear me, Dom?
Yeah, we lost you a little bit there. I think you said the reason for that is...
I think I'm back.
Don't worry.
Yeah, unfortunately I paused in time. I think I got a bit of a warning on that one. I can only apologise where it's done. Yeah, one of the main things is with timber, essentially it's a carbon sink. Forests are carbon sinks. As trees are growing through photosynthesis, they're absorbing the carbon and they're locking that into the timber itself, into the wood. Now, they're most productive at locking in carbon over sort of the initial up to 30, 40 years of its life as it grows. And then there's a certain point where actually the growth slows and the volume of carbon that they're able to take in is actually limited. So there's actually a lot of arguments for why it's beneficial for managed forestries and then utilising that timber in the construction industry, because as you allow a tree to grow, it locks in a certain amount of carbon. At some point, it plateaus off in terms of the amount of carbon it can take in. Then the timber industry is able to then come essentially cut down some of those trees, but you're not losing that carbon once you cut them in because it's locked into the timber. So then what you're able to do is then convert that timber and essentially that carbon store into a construction product and then lock that carbon into a building. So for every mass timber building, all the timber that you see in there, that has got locked in carbon for its entire design life. The question always becomes on the design of cradle to grave and how that operates with different projects, and that's a consideration for every material. But the fundamental principles around timber construction and sustainability is that concept of locking in that carbon. So buildings can be your carbon store, your carbon sink. So you can convert a town, a city into a carbon store itself, at least within the construction materials you use, in comparison to steel and concrete. You always need steel and concrete. They have their place. You need your concrete for your foundations. There's always certain designs where you want steel. So it's always about considering where is it appropriate to use timber and where is it beneficial, especially when you're coming from a sustainability side. And that's kind of the main principles behind it. It's about locking that carbon within the structure itself as a material. For example, with the concrete industry, to produce concrete, you obviously have to, you're digging materials out of the ground, aggregates, creating sand, transportation of that, and then so you're actually emitting the carbon as opposed to containing it throughout its lifetime. And the same with steel, the amount of energy that's required to through the fabrication process of steelwork. So there's always some, with the forest industry, you're still obviously cutting down forests, there's still processes, there's still factories, there's still transportation, but it's all about considering sort of gross versus net.
Awesome.
And
very, very nice.
The fundamental principle is the embodied carbon.
So I think
and how
another
much can you
topic
retain
which
that timber and
touched
that
on
building.
before, I know obviously with the steel staircase, you mentioned the fire aspect of that as well. So just moving on to our kind of next topic of conversation, which is everything to do with fire, but how do you kind of approach fire resistance when it comes to timber construction? We're talking especially in the larger scale buildings.
Yeah, so essentially there's a few approaches to fire design with timber. Now, the key thing to know about timber is, especially in this current climate, timber is technically a combustible material, but the main thing with timber is it chars, and it chars at a known rate. And the principle of charring in timber is that it creates an insulation layer, so a sacrificial layer that you can build into an element that you allow it to char, and it then protects the structural thickness that you acquire behind. So there's a few, depending on what you're designing for and what the building regulations require. So typically you're looking for a load bearing resistance. So I suppose something I always like to make sure that I kind of discuss with design teams when we're working on projects is understanding what are the compartmentation requirements of a building. Do you need R, E, and I? So load bearing resistance, insulation in regards to temperature between compartmentation areas, as well as then the integrity for how does smoke and gases move through a wall buildup. So a key question is, where you have timber structure, does that need to be that full, does that need to achieve the full R, E, and I requirements of those? Now, typically within building regulations, almost every structure will require the load-bearing structure to have a R rating. So, for example, the load-bearing capacity of a building is it doesn't need to be 30 minutes, 60 minutes, 90 minutes. And then how do you achieve that? So the basic way to approach it is it can be lined. So you can line that with fire-rated materials to achieve all of those that are the E and the I. Essentially, the timber structure, and this applies to concrete and steel, they can just be boxed in, intermittently painted, etc. And that can be taken care of by others, by a lining contractor, etc., and be dealt that way. And you're looking at essentially partial encapsulation or encapsulation.
Technical issues. I think Josh will be back
But
in just a second.
The beautiful thing with timber is because it chars. I think there's a lag, and I'm going to drop out. No.
So you were talking about the contractor. You only disappeared for a second, and then you're back. Don't worry.
Okay, I think I'm back. Apologies. Yeah. So I thought I did there. So I'm in a new little side office room, and so testing out new connections. So hopefully it'll hold out. So we're talking about RE&I and how essentially you can do partial encapsulation or full encapsulation utilizing linings. So you're not using the timber to actually protect itself from the fire requirements or achieve the fire requirements. However, what we do in majority of our projects is we achieve the R rating, so the load-bearing capacity in line with building regulations of 30-60 minutes through the charring of the timber. So essentially you'll design a wall thickness, a column, a beam based on the structural capacity. And then essentially what you're doing is you're increasing that thickness or depth, if you're looking at a beam, to allow for a sacrificial layer of timber, which can char for the duration required. So timber chars at a known rate. Typically, it's around 0.7 millimeters per minute. And this is all within Euro codes. So this is codified within European technical standards. It's then covered by ETA, so European technical assessments with different manufacturers and essentially producers of the product. So whether it's glulam, CLT, etc. So it's all covered by there and through with a lot of testing and test data that backs all of this up. So it's all known char rates. And that's whether you do have various char rates, whether it's a horizontal element being a floor or a roof, or a vertical element like a wall. So there are various there are varieties in terms of the different how the timber actually reacts to fire and chars in terms of the rate, but it's all known. So as long as you bring in a specialist, they'll understand how to apply that in terms of and how to design the thickness to account for that, the required load bearing capacity in line with building regs part B, so for the 30 or 60 minutes. And it's kind of as in a simplified answer, that is essentially it. You're accounting for the charring and you're looking at that. It gets a bit more complicated when you look at the E and the I, and most of that isn't to do with the material itself or the products. Like CLT in itself can achieve even like a 90 mil thick wall panel could achieve REI 90, for example, so 90 minutes because of the way it's cross-laminated and glued. But where it becomes more complicated and complex is in all the junctions. So where you have openings in a wall, where you have to panelize the system and you have joints, how are those being designed to not achieve the R, but how are they achieving the E and the I, so the insulation and the integrity. But again, that is all achievable. It's just working with the design team to understand where are these requirements needed in a building and which is the appropriate method for it to deal with it within the timber structure.
That was very well put and very well explained there.
And there's all pros and cons to both.
I think, this is just, what I'm thinking about here is, what is your opinion of the acceptance of the use of mass timber as an alternative to, let's say, the likes of steel or concrete within the industry, particularly when it comes to speaking to clients about things like fire regulations? How have you found that it's kind of been adopted by the wider industry?
Well, historic, even it's not really that historic. So in terms of CLT and glulam's been around for essentially 170 and close to 70 years ago. So glulam at least 100 years. I think the first CLT building was actually in the 50s or 60s on a small scale house. In terms of in large scale production, especially in the UK, around 20 plus years, but only around the early 2000s really it came to the UK, and it's really been developed as a mass timber solution available to the market. And the UK was really a pioneer of the CLT. At one point, we were hitting some of the taller buildings. I think it's Murray Grove in central London. I think that's around 10 or 11 stories, residential block, fully timber. But you can see how the industry is sort of having to catch up, or the building regulations are catching up with the industry, and we saw that following post-Grenfell. and how then building regulations weren't necessarily changed, or well, the review happened, the Hackett review, etc. And there's a lot of developments within building regulations. The use of combustible materials was limited within external walls of residential buildings in high rise, so above 18 metres. So post then, the industry's had, I wouldn't say a fallout, but there's been a lot of discussions around the use of mass timber, especially CLT, where is it appropriate? But essentially, we're in line with building regulations and what you can do in this country. You can go up to 18 metres, 18 metres being your firefighting height, and you can have a complete mass timber building, including the external walls. So it can be a full panelized system. It doesn't have to be looking at a post and beam option. As soon as you go over 18 meters. So I suppose to put that into context, that is essentially the building that I showed you before. Let's hope that this doesn't throw out the stream again, just to show. So this is up to 7 stories. Now this is under the 18 meter cap. It is on the limit, but this is why we're able to build with CLT in the external wall in the UK at this moment, using
we'll get
mass
Josh back
timber
in
and solid
a
timber
second, but yeah, maybe that image is thrown out the stream a little bit there. But yeah, we'll get Josh back
I'm
in
not
a
surprised.
second.
I'll just cancel that.
Yeah, but you can see. Yeah, I think that image is thrown out the stream there, Josh. But no, that's absolutely fine. That's absolutely fine.
Yeah, but, I thought it might. I might have to limit those for now and see if maybe I can share some afterwards. So I can only apologise. Yeah, so essentially we can go up to 7 stories in the UK, more or less, 6-7 stories using mass timber, including the external envelope for residential buildings. There's still a lot of conversation around that. There's a lot of different reports and literature that are being put out there. So one of the largest ones, I don't know if we'll have any architects tuning in with us. I know this is Engineers with Ideas, but War Thistleton, they're a big driver of timber buildings as an architectural practice. Essentially, they're one of the leading practices in the UK and also operate globally, pushing timber design and use of timber. But what they've released recently is a document called the New Building Model, which is a really interesting document. This was produced in line with the insurance industry as well, because that's some of the biggest concerns is around insuring the building. And that's where most of this is coming from. You've got the building regulations requirement from a health and safety point of view, and how a building's designed, and then how much then the insurance industry actually impacts that when you start talking about residential buildings and how that's developed. So that's something War Thistleton took a lead on, which in some respects was brilliant. And the document is actually a really good reference document. I would advise anyone who's looking into mass timber or CLT, especially residential, multi-story residential projects, even if it's only mid-rise, to look into that, because they call it the New Building Model because it's looking at using mass timber from the sustainability point of view, because they understand the need for that and why it's such a positive use of material. And what they look at is actually the detailing and best practices, whether it's to do with fire, moisture, just general detailing and protecting of that. And one of those topics that they do pick up on, and just one thing I find it's an interesting discussion point, I've not been able to have it with many people yet outside the office, is they essentially advise not using mass timber in the external wall below 18 metres as well. So, and I believe a lot of that is being driven by the insurance industry and what they were developing that with. So there's still a lot of movement happening in terms of where and how we should be applying mass timber. But I think the main thing here is this is all talking about residential buildings. So building regulations is always talking about, it's all about risk. It's all about performance. And then when you talk about fire, it's about risk. And so when you're talking about fire, it's all about, well, what is the risk category of the building? And then what is the requirements that it needs to achieve? So with a residential building, you're staying overnight. People are obviously asleep during the evening. So the risk category, if a fire was to break out, for the people to actually be able to escape the building, that's where that all comes from. So they're really going down the conservative approach, which is actually above and beyond what building regulations are requiring. So what you can build in the UK currently is up to 18 metres with mass timber in the external wall. But we're starting to see now a lot of literature, well, not a lot, a few pieces of report writing coming from certain architects and certain people in the industry and within the architecture going a bit more conservative on that. And that's not necessarily a bad thing, and it's keeping the conversation going. So it's really still a developing environment, fire design within timber. But the main thing is it's all in line with Eurocodes, it's codified, we understand the material. It's now getting into the nitty gritty of how the modern world works in terms of requirements for test data, confidence within building regulations. So a lot of building control officers are actually independent officers, not part of them. So it's their own individual PI that they're putting up against a building and how that's then able to be insured. So there's always a lot of hesitancy within the industry. And that's not just from a design side, that's all the way through to insurance and essentially just getting sign off through building control. So the industry is really trying to work together to establish this, because obviously we all want to design not just beautiful and good architecture, but safe, structurally sound buildings that will last the design life. Because when you start talking about sustainability, you want it to last that 50 to 100 years. We're still in Victorian houses, most of the country. They've been around for over 100 years. So we want to keep building in that way. So obviously, typically we're designing for 50 years for most new buildings in the UK. So we want to make sure that our buildings last that long, whether that's from a fire design or moisture. We want to make sure we're detailing, we're supplying buildings.
I think it's really well put there.
Really are going to help us in the current
kind of leads quite nicely on to the
crisis
next section, where we're going to get a little bit more involved in the technical aspects of mass timber. But from my perspective, I am seeing a lot of talk about the use of mass timber in the industrial or logistics sector. So large warehouses, which obviously have large spans. But I know a lot of people that I'm speaking to are thinking about how mass timber is going to compare to steel when it comes to those large warehouses or large spans. So I was just wondering if you could share some light on that, about how we get those larger spans with timber.
Yeah, I mean, it's all achievable. Everything has their limits, even steel. When you think about large span, even in steel structural design, is it just a single beam element, or are you talking about a truss? And a lot of the time when you're achieving these, it's a truss system that's achieving these, a lot of like these logistics halls, etc. And it's exactly the same approach with timber.
So lost Josh again, but we'll carry on at truss
we do quite a few sports halls as well.
It was a truss system.
Dropped. Yep. I'm back. Yeah, truss system. So essentially the same with timber. So we've delivered quite a few sports halls as well. I'll save sharing any images till the end, just to try not to throw, and we can try and go through a few projects potentially if we have time. And I can demonstrate some of the things that we've been talking about. But we've done a few sports halls, and so between 20 and 30 metre span beams. One of the halls recently, only last year, was a 24 metre length beam, and it wasn't a truss. It was just a solid timber element. It was around 1.6 metres deep, so the depth has to be accounted for depending on the architectural design. So you do get larger elements to achieve clear spans with timber in comparison to steel. And that's just looking at solid elements. Then you get into the truss systems as well, which of course you can achieve. I mean, just look at typical traditional design, whether it's church roofs historically, timber frame, the timber trusses, through to our modern, like current housing, and especially how we build houses in the UK, they're trusses. Fair enough, they're not logistics halls, but in terms of, if you think how timber can be applied to create a structural framing and a structural system, timber has been used to create these in so many ways throughout history. And now with the use of engineered timber, so like glulam, you can then use a glulam truss system to achieve them. So we're seeing quite a few of the logistic halls come through. And if it's not the logistics halls, it's the data centers or the offices connected to a logistics hall, which again are still huge buildings and office commercial spaces with large grids, where they want a grid of more like 9 to 10 meters.
I think he was on data centers there. But it was very interesting what he was saying about trusses. I didn't think if it was going to be single span or a truss system with mass timber. But I think that's quite an interesting thing to think about there. So you're on data centers.
Yeah, I don't think you'll ever invite me back, will you? At this rate. Yeah, exactly. Yeah, I think I'm gonna have to work on this connection. I do apologise. Yeah, so we see a lot of these. We're starting to see more of these halls come through, whether it's sort of the logistics halls or data centres, and clients wanting to use it. So it's being driven more by the clients than by the industry itself. So people are wanting to use timber where they can, because they want to start having that sustainable material and looking at how they can have as positive an impact as they can with the materials they specify for the project that they're working on, and whether that's the architect or the client. And we're seeing a lot more being client driven. But on the more technical side, with like the truss systems and timber, they can be achieved, and how you then achieve them.
Apologies for the technical difficulties there. I think Josh is all good to go. I think we left off at talking about the kind of the data center to market and timber and long spans as well, and in comparison to the steelwork side.
Yeah, exactly. And we're starting to see more and more of those come through. A lot of that's been driven more from the client side in terms of their wanting to use them. So it's becoming more of an opportunity for the industry. In terms of the structural design of that and how we can achieve them, there's always going to be limitations. So you can say a logistics hall, but again, how wide's a logistics hall, right? How long's a piece of string? So it's all project specific, but usually there is an opportunity for the use of timber through large trusses. So with a logistics hall, typically you get the height in the space to enable the depth of a truss system. So it's just working with the architectural team to work out, do you have the depth and the space to actually enable having a truss system that's appropriate? And then, of course, there's always the question of commercial cost between the two and what's the most efficient. And it's always a question of priorities, what's available, what's the design brief. But essentially, you can achieve them with timber. You'll see them a lot. You'll see a lot of stadiums, especially in Europe, a lot of ice hockey halls, ice hockey rinks. There's some incredible buildings out there, and I definitely recommend people to look into them. Just simply search timber ice hockey rinks in Switzerland, for example, and you will see some large span timber trusses covering those spaces. Think of swimming pools, sports centres. There's a lot more available these days in continental Europe in comparison to the UK for those, because they're close to the timber industry, so they've developed it a lot more. We moved a lot to brickwork historically and masonry, and for our own cultural reasons in the past, and now we're starting to see that movement back again towards timber.
Awesome. Just going into things a bit more technically, I will be honest with you, I don't understand any of this question at all, but it was a question that we've had through. But someone was saying for my dissertation, I enhanced the strength of timber using BFRP rods, but I face challenges with fire resistance, particularly when using epoxy resin. What are your thoughts on this?
Going straight into some technical things. So there's a lot more context potentially will be needed, exactly where and how they're reinforcing their timber element. I imagine it's a beam that they're reinforcing. Now the question is, are they using that in a connection? So they're doing reinforcing rods around a connection. Is it because they've got notches in there? Is it around a support in bearing? So there's a lot more context that I'd need to understand exactly why they're using that, and potentially is it to do with splitting of the beam. So you can really get into the nitty gritty here, which I think is quite difficult. I think that's quite a very technical question, which I'll definitely suggest. I can share my email and people can always give me or look me up on LinkedIn. You can drop me a message if you've got a more specific question, because I think there's a bit more context that I'd need for that. But essentially, when you start bringing in things like resins, there are obviously additional knock-on effects around fire design. And then the question around that is, what is that element doing? So for example, in connection design and reinforcement, is it needed? Does that connection, so does certain screws need to be protected in the fire case? Because what is it doing in the fire case? So there's a lot of considerations around fire design, especially when you start getting into connections outside of just the standard section size that you'd be looking at. So no, that's an interesting question. I'm interested to know in what context they're reinforcing the beams, to be honest. So I don't think I can go too much more in that in this instance.
No, that's fine. And I think someone was asking a question about if you could talk a little bit more about the use of mass timber and also kind of concrete, in particular composite concrete as well, and those particular connections.
Yeah, certainly. So why would someone look to use a composite slab is always sort of the first question, and usually it's to essentially enhance the stiffness of the CLT. One thing with timber is it's a pretty stiff element, but especially when you think of a solid timber element and you think of vibration design. So if you think of a solid timber table, if you knock on that table, it vibrates, you can hear it. So acoustically, it's vibrating. And that's the same when you talk about vibration in a space for how you experience. If someone walks behind your desk right now, because they're walking, does it cause your table to shake and your computer screen to shake? Ideally not, because someone's considered the stiffness of the floor system and the structural system so that the bone's stiff enough to not allow that to happen, and you design for that. And a lot of the time, that's where the composite comes in, because it can add a lot of damping. It can really help with the vibration side, as well as giving you some composite action for when you think of beam design of tension edge and compression edge, and how you can utilize concrete and timber together between the compression capacity of the concrete with the tension capacity of the timber, and how that can actually enhance the performance of a floor system and potentially reduce either the structural depth or just to achieve a higher stiffness, especially when you think of buildings which require a screed as well anyway. So it can really double up on a few elements at the same time. We don't see too much of it in the UK at the moment. It is coming through. A lot of it is, you see a lot more in Europe. They're always pushing different boundaries a little bit more. And I think just the way that typically their on-site trades work, it kind of works with sequencing and just again, how their on-site practices allow them. Because again, you're bringing in a wet trade. Well, potentially not, but typically it's a wet trade coming in after a dry trade. So you've got timber, you're doing a lovely dry timber building, and then you're bringing in a wet trade to come in and apply all that concrete. There are now some people are looking at prefabricated systems, so doing the concrete in the factory or the warehouse with that. And again, it really depends on what's the rationale for it. Is it a structural side? Is it a vibration side? So more of an SLS of serviceability, design requirement, where it's coming from. But it does have a lot of different benefits, but you really need to weigh up, is it worth it? Is it needed? What's the knock-on effect as well, because of whether it's cost or installation and sequencing of these elements within either manufacture or installation. Connection side's really quite interesting with them. You're essentially creating shear keys between the CLT, the timber deck, and the concrete. So essentially you're routing out sections of the timber and potentially putting fully threaded screws in. So you're creating a shear key where it gets bonded to, very similar to the concept of if you're connecting a concrete slab to a concrete column and you leave the rebar exposed at the top, so you can make that connection between a column and a raft. You're doing a similar thing, just using screws into the slab so that the concrete can bind to that, and then you're utilising the shear capacity between those. So there's quite a lot you can get into with composite. It just really depends what's the rationale for wanting to use it, what's the design consideration that you're looking at, really.
Okay, brilliant. And then just the final technical question that we've got. So they were talking about the codes and that it doesn't include the use of flitch glulam. They were saying, is there any particular reason why this hasn't been done and why that's not in the codes?
Can you still hear me?
No, yeah, you're back. Yeah,
Perfect.
you're back.
So I've got a spinning wheel, I was worried. So the main thing with the current codes, I believe EC5, Eurocode 5 for timber design, I think that dates back to more to 1995. Obviously there's been national annexes and things that come through up to like around 2014, and there's always things that come through to update them. The next update I think was meant to be released at least 4 years ago. I think it was originally due out 2020. So the next version of Eurocode 5 is expected over the next couple of years. And as I understand it, I believe they are looking at including flitch beams. Now, the main reason why was it not included before, because when you're talking about a flitch beam, especially for context, if anyone's not aware, or just for extra context to what we're talking about, you're talking about two timber elements with a steel plate in between. Typically, when you're talking about flitch beams, so you're utilising the timber and the steel. Now, when you're designing these, you're not designing a composite element. It's all about load distribution between the two. So therefore, when you're then designing the steel element, you're designing that to steel codes. So you're not designing, so it's a grey area crossover, which is why it's traditionally or currently isn't included in the code, but it's something that they're looking to include. So at the time, widely used, you see them a lot. You can even buy them as almost standard products. There are certain people out there, probably more in Europe or even continental America, USA, sort of in the United States and North America. They use them a lot more than us, and so there are people that do actually offer them as almost standardized. So because you can, from plate sizes and glulam or timber beam section sizes, but it's just not something that's been done that much in the UK.
Josh will come back in just a second. He's talking about continental Europe and I think South America there. I think he's going to come in back now. Yep. Sorry, Josh, we had you at continental Europe. Yeah,
so essentially they're probably more widely used on the continent in certain places or North America. But again, it's kind of that fundamental reason, I think, on the design, on this, how you actually design a flitch beam, whether it actually needed to be incorporated in the codes. But as I understand it, they are looking at including the chapter in the next version of Eurocode 5 to cover flitch beams. So it is coming. And it's just understanding how you design them really and whether they need to be. So you can definitely design them without. It's just understanding what you're designing, and you're not actually designing something composite. So there's ways around it, and it's you picking and choosing the codes as you need them to design the individual elements of essentially a component.
Awesome, mate. Awesome. I just didn't think about that. If there's a steel element in the middle, like which code it would actually go to. So that's quite interesting. That there's probably still a lot to be done when it comes to merging the two materials together and which code it goes to as well. Okay, interesting. So just leading on to just the wider context then. So what can everyone do? Because I know a lot of people are so passionate about the use of mass timber, and sometimes, whether it be from a client perspective or maybe it just not being pushed enough in the office, like what can people do to promote the use of larger scale, more complex timber projects?
So I think, I mean, number one for me is understanding. Understand the material. If you think you want to use it, do some research, reach out to companies like ourselves, Urban, there's other people in the market, Trada, TD UK, so Timber Design UK. There are webinars available. There are CPDs available from people. We ourselves, we do offer CPDs, typically online at the moment, but we can offer them and really get that understanding of why would you specify it. We want people to specify it. Because obviously it's the market we're in. We're all in this. Pretty much everyone in our office is driven by timber. Everyone came here because of the want to work with timber, whether it's from a sustainability side, architectural side, because you can expose it, and biophilic design, etc. We have a lot of architects in our office who are project managers. So there's a lot of reasons why you'd want to use and work with timber. But the main thing is to understand, okay, why do you want to use it? And really build that knowledge. Because once you have that knowledge, you can help that with your design team, and then you can express that with the client especially, and a lot of times getting client buy-in, and it's understanding why is it beneficial. I was recently at the Timber Design UK at their inaugural timber conference in London earlier this year, and I attended that, and it was really quite interesting because they had a couple of insurance brokers, commercial developers, because there's been quite a few commercial projects in the UK, especially in London, where they're either new commercial buildings or they're building additional stories onto existing. And by doing that, they're looking at using hybrid structures or timber or solid timber and mass timber structures because it's a lighter element. Timber is typically a fifth the weight of concrete. So immediately, if you're trying to build up above on top of an existing, you want the lightest frame possible because you're trying to utilize existing foundations and structure. So it was really interesting hearing someone who's actually on the development, side. So they weren't in the design, they were essentially the specifiers and why they were looking at it. And there was at least 2 or 3 there who spoke, and they mentioned something to do with cost, and they found that mass timber was coming in, options were coming in around 3 to 5% more expensive than maybe a steel frame. Now this is on commercial projects, and I found that was really quite interesting because a lot of the time you get that question, is it cost comparable, is it competitive? And that gap is closing 3 to 5%. So if you compare that, that could be on a large project a large part of a budget, but at the same time, what is the rationale for wanting to use timber? So is it because of the sustainability side, because you're wanting to use a green solution and you want to trap in carbon, you want to make a positive impact in the world with the buildings that we're designing and within our industry? And if it is 3 to 5% that higher cost for pushing it that way? And the more that we do design with it, that cost will close down. And I think it's understanding all these variables and in terms of why do you want to use it, and it's essentially selling it. And why would you? I think I'm still here. Can you hear me?
I think we've just lost Josh in his flow there.
Okay, I think I'm back.
Back. Yeah, back.
Yeah,
sorry,
I
carry
apologise. Yeah,
No
I think for me, it's considering. It's not just considering why would you use timber. It's also the question, why are you using steel or concrete or any other material? What's the rationale for any material you're using? Are you using one just because it's a norm? Are you using one because whether it's cost, is it because of efficiency, is it just because how things have always been done? It's not always analysing what's the new option that you want to look at. It's also analysing, well, what's the current option you're using and why, and then actually weighing them up together. And I think when people start to do that, you start to understand the potential benefits or potential reasons for using and specifying mass timber and timber solutions. Because I think it really starts to come into its own when you start to account for that. And I think the key thing here is, obviously, I'd love a full mass timber solution, but it has to work with an architectural design as well. We have to utilise steel, whether it's beams, columns, you still need a concrete foundation. So every material has its place, and it's just considering your design. Where's the appropriate place to use timber? Because you also don't want to be putting excess timber into a project, because as much as you're storing carbon in that one building, some of that could have been used somewhere else, and we're still extracting others. So there's a lot of different ways you can look at it, and there's pros and cons to every material, and it's just really assessing them all and trying to bring it together.
So just before we sign off, Josh, I'm just going to experiment by switching off my camera and mic to see if that gives you enough streaming power to share the project. So if it does, great. If not, we might have to sign off. But what I'll do is I'll just switch off my camera and mic, and let's give it a try, see what happens.
Okay, right, perfect. Thanks, Don. Right, we're into the world of the unknown. I'd just like to apologise to everyone for my connection today. We've recently moved into a new floor on the office with new meeting rooms, and I've given them a go. And apparently, the connection that I've been using hasn't been perfect. So let's just try share this screen. So I think we're working. Okay. Don, please step in if this stops working at any point. So, as I mentioned before, we operate on a few different sectors throughout the industry, whether it's commercial, education, residential, and sort of everything in between. So what we showed earlier was the Cascades project, which was this one here, which is in Cardiff, 7-storey, multi-storey residential project. It has at least 4 or 5 units per floor, with some commercial units at the ground floor. So this is a great demonstration of what can be achieved under building regulations currently, and what the industries and within the UK is trying to push back towards, because you get buildings this height, if not taller, throughout the world, still using timber, and it's something that we're still trying to develop post-Grenfell and understanding materials. Now, moving on to another. So as I mentioned then, we talked about some long span beams. So here's a demonstration of this. So a sports hall. I'm hoping I'm still sharing. So I'm just going to flick back to test. I believe I am. So this is a sports hall. So these beams, this is for it's called Wellness Centre. It's in East London, out towards Epping Forest. These beams are circa 1.6 metres deep. They're 24 metres long. The span of the beam actually goes past this wall here and to the external wall on the side. That's a viewing gallery. This is to be a basketball court, in line with Sports England design requirements for basketball court and tennis courts going the opposite way. These beams are around 1.6 metres. As you can see, these are solid glulam elements. These have then been pre-cambered as well to account for any dead load deflection. So that can also be accounted for within glulam to aid with the SLS design. And this is what you can achieve within mass timber as solid elements without even going towards truss systems. Of course, architecturally, maybe a truss system could be beneficial, and you could utilise a truss in this scenario too. This was the architectural intent which we're looking at achieving. This is another area of the same building. So again, what you can see here is this is a first floor. It's still 3 to 4 metres tall. You've still got a 24 metre length beam. And in areas we're utilising mid supports as CLT walls, as well as central steel columns. So again, steel has been introduced because of it being able to be a lower profile, so it could fit within a partition wall that will be going in at a later date. I believe this building is either complete or due for completion over the next few months. We completed on this back in the summer last year, so it's been going on to fit out since. This will be a gym space and dance studio area, and you can already see the use of timber and sort of the lightness of it, even though the walls are all boarded out. What you can see on the floor here is we used a membrane pre-applied at factory on all floor slabs to do moisture protection. That gets pre-applied at the factory, which is definitely critical on visual projects to avoid moisture staining during the build. And it's a temporary protection where the membrane stays on for the life of the project, but it's there for the temporary during the build, so that we can manage the moisture and the water. So, for example, from rain that could pool on the slab, we can manage that throughout the build. And essentially, we then put in a moisture management plan to ensure that that water is being brushed off the timber structure in appropriate locations. And then on top of that, we monitor the moisture content of the timber throughout the build. So that's both visual inspections, so understanding where you can visually see moisture ingress, and our experience of understanding where that's an issue, where that's high ingress, where that's low, through to actually taking hammer probes and moisture probes to take moisture readings. Timber typically comes out of the factory around 10 to 12% moisture content. For linings to be applied to timber, you want that moisture content to stay below 17. During winter, it will naturally, through equilibrium, due to temperature and humidity, go up to around 15, 16%. So you will get close to that 17, even if it hasn't rained, potentially, during winter. During summer, it can dry out to about 8% if it's in direct sunlight. So there's a lot of variety in timber moisture, and it will change throughout its lifetime. timber will shrink, it will grow, it'll absorb moisture, and it will find an equilibrium as a hygroscopic material. So it's all about understanding the material and then how we detail and design that from our side, manage moisture on site. So that's just a little bit of a crash course conversation on that there. So if you have any question on that, again, you can drop me a message, drop Dom a message for engineers with ideas, and we're happy to elaborate where people are interested or have questions. And again, yeah, you can just create these interesting spaces with timber design. I've got a feeling I can hear Dom in the background. Does that mean I disappeared for a bit?
No, you're absolutely fine. Absolutely fine.
Brilliant, it worked.
Perfect. Yeah, that worked absolutely perfectly. Was there any more images to show, Josh? I think that was.
I mean, there's always a few. It depends what people are interested. I think in terms of just scope, I find this one really interesting. This is a project which we've just completed on, and this is a school project. And so again, the use of timber in education, so biophilic design. But what this is interesting is a staircase. So the use of mass timber in a staircase. The actual stair element here is solid timber. There's no steel here. It's made up of 5 elements. The balustrade is one fabricated piece, and then there are 3. The flights, the half landing, and the flight is an element, and it's got cantilevering half landings at the top and bottom for the slab to stand in. And then I think there's a picture. So again, the use of mass timber in a local area. Here we go. And so the staircase there, showing the atrium space. And here we go. And then how you can utilize mass timber for feature staircases as well, and how timber engineering can be quite flexible, and you can do quite bespoke designs, and how understanding the material enables you, and not just the material, but understanding the fabrication processes and limitations, you're able to design and build elements like this. And actually we can fabricate solid CLT stairs, so an entire flight can just be one element which gets craned into place. So that is one solid element where the treads are actually routed out of a solid timber panel. And then it gets fabricated on the ground together, made up on the ground, and then it can be lifted as one. And that's probably where there's always more I can show, but I think for now I'll probably leave.
If there's one more or a couple more you can show, I think
sure.
they were quite interesting. Let's just keep it rolling. We don't really need to worry about going over time
let me
too
share
much. But
again.
if you show a couple more, that'd be great.
The internet seems to be working. So I'll close that folder. I suppose then the opposite end of the spectrum, private houses. We've done a few on the island of Jersey, so out in the Channel Islands, so off the coast of North France. So again, private residential houses. This is obviously quite a bespoke, high-end house. This was using a French CLT supplier, so it wasn't using spruce. This was using pine. So again, different suppliers may use different timber species within, and you'll get a different visual quality or and a different feel. So this is a lot more orangey and a deeper colour than what you'll see in a lot of the UK supplied CLT. And again, using timber design in different scenarios, how you can cantilever them out to create different details, whether it's just for an architectural detail where they're trying to create a little terrace and a light well through. So utilising the CLT as deep beams, so not just as a panel itself, but actually as a beam element, through to how you can utilise that with architecture to create spaces and views. And again, this is on top of essentially a podium slab for a house. So the lower floors is mass concrete and block work that we
have just lost you there, Josh. So may have to be just the last few slides. This one.
No problem. Probably a bit too quick. So we can do everything from private residential all the way through, and mass timber can have its place in creating different architecture, but also different structural solutions. I'll probably leave it there then, just in case.
Awesome. Well, Josh, that goes without saying. You've been an incredible guest. Thank you very much for breaking everything down so simply, so understandably as well. I think it's on a lot of people's minds at the moment, and just hearing from someone like yourself and just explaining everything in depth like that, I know a lot of people will have learned a lot from this session. So just goes without saying, thank you so much for being a guest. Yeah, of course, please watch out. I know it's been in the chats, but we do have our live event coming up, which is going to be Wednesday, the 18th of September. which will be at the offices in Shoreditch with Web Yates engineers, where that will be a panel discussion with myself talking about everything related to support for chartership. So Josh, thank you so much. It's been an absolute pleasure to have you on. Yeah, and we've got over the technical difficulties and we got there.
No, thank you very much for inviting me. Apologies for the technical difficulties. If ever again, I'll ensure that it's a plugged connection. We don't have that issue. So apologies for anyone listening. And yeah, thanks for having me on. And if anyone does have any questions, please reach out. You've got my name, you know LinkedIn, you can find me. I work for Urban Limited. So yeah, please reach out.
Awesome. All right, Josh, thanks very much.
No problem. Cheers. Take care, Dom.